All right, welcome to lesson 1.5, synthetic division. Okay, so far this unit, we've learned how to add and subtract, how to multiply. We learned two different methods for dividing. The reverse tabular method, long division, and then today we're gonna learn a third method called synthetic division. And this is really like a shortcut to long division. It's much, much simpler, and I guarantee you're gonna like it better. So this synthetic division can only work, let me just put my face here. Synthetic division can only work when you're dividing by a linear binomial. So linear meaning just x, no x squared or x to the third, and binomial only two terms. Well, if it's linear, it can't be more than that. Okay, so there's a lot of steps, but looking at it written out like this looks really complicated. It's actually not that complicated. So let me just do some examples, and I think it'll be much clearer. Okay, so here's how you do it. If you have x minus a as a factor, then a goes in the corner. So we have x plus 2, which really is a negative 2, is going to go in the corner. It's basically the opposite sign. Just put the opposite sign in the corner with a little box. Then you write down the coefficients of your dividend, the thing that's being divided. So that's 3, 4, 7, and 22. Okay, then you leave a gap and draw a horizontal line. Okay, so I'm going to say those steps one more time. You put the opposite sign in the corner, then you write down the coefficients of your dividend, the thing you're being divided. You leave a space and draw a horizontal line. Okay, you bring down the first number. Okay, then this is where it gets just easy. Multiply negative 2 times 3 and write it here, negative 6. Then add 4 minus 6, or 4 plus negative 6 is negative 2. Then you multiply, you're always multiplying by this corner. Negative 2 times negative 2 is a positive 4. Then you add 7 plus 4 is 11. Then you multiply, negative 22, then you add. This bottom number will always be your remainder. And so far, everything we do today will have a remainder of 0, I believe. It should. So, okay, now these are the coefficients of your quotient, of your answer. And then you start, since we had x cubed and we divided by x, we're down to x squared. So you just put 3x squared and then just go down a degree each time. Minus 2x plus 11. And that's it. I'm going to show you another example. So what is the result when x to the fourth minus 3x squared? This whole polynomial is divided by x minus 1. All right. So first of all, there's a negative 1, so I put a positive 1 in the corner. Okay. Now I write the coefficients from this whole polynomial. So the first coefficient is 1, then negative 3, then negative 7, negative 1, 10. Okay. I leave a space, draw a horizontal line. I bring down my first term, so that's a 1. 1 times 1 is 1, so I multiply, then add, then multiply, then add, then multiply, then add, then multiply, and add, and this last one is our remainder, which I'm pretty sure all today will be 0, so you should always get a 0 there. Okay, good. Now I started with x to the fourth and divided by x, so I'm down to x to the third. So 1, or just x to the third, minus 2x squared, minus 9x, minus 10. And that is my quotient. Okay, I'm going to go back to this example. This one's a little unique because you see it's missing a lot of values. So just like with polynomial long division or the tabular method, if you're missing a term, you got to put a 0 placeholder. So this is again a negative 1. So I put a 1 in the corner, and I have a 1. Now there's no x squared term, so I put a 0. There's no x term, so I put a 0. And then there's a negative 1. Leave a space, draw a line, bring down the first term. Okay, multiply, add, multiply, add, multiply, add. That's our remainder. Okay, look at that. They're all 1s. We start with x to the third, so it's x squared plus x plus 1. And that would be your quotient. Okay, so go ahead and try this, check your understanding. Okay, set it up. And then when you're done, you can check your answer to make sure you understood it.